In an era of industrial revolution, 3D printing is surging towards mainstream technology. Recently, researchers from Center for Nanoscience and Engineering, IISc Bengaluru, have taken this printing technology to the next level. They have developed an efficient satellite-free drop-on-demand printing technique. The present-day printers use nozzle heads to eject droplets, which have unwanted particles in the ink or cell suspension that clog the opening, thus limiting the amount of particles to be loaded initially for printing. This also limits the thickness of the layer to be printed. And that's where this new technique comes into the picture. It replaces the nozzle head with a mesh which is covered with chemically treated nanowires that repel water. So whenever a large droplet impacts on this mesh, it bounces back, leaving a small part of the droplet through the mesh, which is then printed on a surface. This technique also enables printing of very thick lines in a single cycle. The other good part is the mesh is easy to clean and reusable. Also, its operational cost is much lower compared to other printing techniques. So let's hear more about this technique from the team behind this brilliant innovation.
In drop impact printing, we use the kinetic energy of a falling droplet on a superhydrophobic mesh to generate smaller droplets. The size of the ejected droplets can be controlled by changing the pore openings of the superhydrophobic mesh. This unique way of printing is economical and simple. Nozzle clogging is a major problem in most of the existing printing techniques. In drop impact printing, as the superhydrophobic mesh is used, it doesn't allow the falling droplet to stick to the superhydrophobic mesh, and hence in this particular technique we can print particle suspension with very high mass flow. This is the advantage of drop impact printing technique. This technique can be used to print area of live cells, bacteria. This can be also used to print electronic circuits, and this can be also used to structuring functional nanomaterials.
The question is, how does this droplet ejection take place? And more importantly, why does it take place during the recoil phase? Upon further investigation, we found that when the droplet hits the superhydrophobic surface, a cavity is created at its center. And when this cavity collapses, the momentum of the interface is higher than the momentum of the actual impacting droplet. This leads to formation of a jet, and which breaks to give us a single droplet.
In bioprinting applications, reagent mismatch is a major problem. With drop impact printing, we can print droplets containing live cells ranging from nanosize to microsize with very high precision.
Moreover, for circuit printing and 3D structure printing, this technique performs well. The thicker line printing in one go gives us the required feature and properties. This not only saves time but also maintains the integrity of the structure.
This innovation can be used for 3D printing of different sizes using different inks, ranging from semiconductor devices to cell culture. Thus, the precise and affordable approach of drop impact printing makes it a top-notch printing technique. Hope you like this video. Please do like, share and subscribe to our channel. Jai Hind.